So hello, I'm Wolf. I'm from a company named Soroco. This is our second time attending PyCon India. We came for the first time last year. We attended PyCon India in Delhi, and now here we are in Hyderabad. The title of this talk is Python, Batteries Included, Now Bulletproof 2. Everything I'm going to talk about today is actually now open source. We had promised it last PyCon, now it's finally open source on GitHub. And everything I'm going to talk about today is also demoable. I was going to show a live demo, but we swapped laptops, so I can't show you a live demo on stage, although I love doing that. But what I can do is I can show you a demo in our booth. So this year, we're here in force. We have about 6 engineers with us from our company. We came in from Bangalore. We're all in the booth back there, the Soroco booth, and I can show you a live demo back there. So we do a lot of enterprise business automation, and in the enterprise, we wanted to protect the code, both for our customers and ourselves. If you look around the Python community, there's not really a lot of great options to protect your source code or even your bytecode. In fact, this is straight from the Python wiki. There's 3 broad categories of options for you in the normal Python community. The first is a category called obfuscation. You could compile your Python source code into bytecode, but bytecode can easily be decompiled or reverse engineered. You could use an executable. So there's a lot of Py2exe, Python to executable creators. But an executable is just a simple black box that can be unpacked again, and you could actually get to the source code. You could also just use an outright actual source code obfuscator. But all it's going to do is rename your variables, insert code, delete code, play games with the source code, but again, it can be reversed. The next 2 options are a little bit better. So you could turn to static compilation. You could use something like Cython. But Cython's not perfect. First of all, not everything will play nicely with it. And again, it's really just a transformation of your Python to x86, which can still be reverse engineered. The last option, however, which is suggested on the wiki and is a general technique, would be software as a service. And this works really well, but you have to run it over the internet. So our solution to this problem, which we can demo in our booth, is PyCE. It's a new file format that can be imported into Python. I'll show you the API. It encrypts your Python code with strong encryption using AES-256. The keys, we don't solve the key distribution problem, but in our typical deployments, we use HashiCorp's Vault or a similar product like CyberArk's Secret Manager, and we would load the keys over the network. Key distribution and key management is up to you. We use a network-based server to manage keys. At import time, this file format is imported into memory by Python, decrypted using a key, and then you can execute normally. I'm going to quickly show you the API. I can't show you the live demo on stage. Again, come to our booth if you want to see the demo. First off, we offer an API to encrypt your Python code. This function is actually recursive in nature, so you can run it on an entire directory, an entire module all at once. The output of it, it would convert your bytecode, and we could actually do a Python file as well, but it will convert it to what we call a PyCE file. The extension will actually change. This ensures that normal Python interpreters don't try to accidentally import encrypted files, and only when you're ready with the setup or boilerplate code, which is shown here, would you actually be able to import it. So this is the other half of the API. When you want to go and run it in your runtime, you need to do something like this. So the first line, you're importing a special class that we've created as part of the PyCE library, again, open source. You set up the keys. These could come over the network. They could come from another source. It's up to you. You import sys, and then you hook into metapath. Once you do this with metapath, you actually change how import works. Your Python runtime could then import these encrypted files as long as it has a key. If it doesn't have a key, it'll raise an exception. And then you could actually run the code normally. In this example, it would have just printed a hello world kind of thing. I want to stress that we are open sourcing production code here. So we've used it in production for years now. It's protecting over 50,000 files across all of our clients in over 2 million production executions. So this code is fairly well battle tested that we've now open sourced onto GitHub. In addition, I'd like to stress that the performance hit is only on import. So only when you load the files do you get a performance hit from decrypting the code. Otherwise, there's a zero overhead on your actual runtime. The last thing I want to mention is that we are also contributing to the Visual Studio Code community. So we're putting back, again, for secure coding practices. We're adding to linters Bandit, which is a secure code analyzer, static code analyzer. And this is the last slide, which is the most important. If you don't come by our booth, take a screenshot, take a picture, whatever you can do. But otherwise, let's see you at our booth.